So today I'm going to be telling you guys how to solve the AP Calculus AB FRQ from the year 2014, number 6. The number 6 tells us to consider the differential equation dy over dx is equivalent to 3 minus y times cosine x. Let y equal f of x be the particular solution to the differential equation with the initial condition of f of 0 equals 1. The function f is defined in all real numbers. So let's begin by looking at part A. Let's look at part A. The slope field of the differential equation is given below. Sketch the solution curve through the point 0, 1. So essentially what we're doing is just using the slope field given. We don't even have to draw a slope field here. Just use the slope field given to create the curve. This is what the curve should look like, and the point system for this curve is just 1 point if you have the correct curve. Again, you just follow the slopes that are given and make sure that you include 0, 1 in your solution. Part B of number 6 tells us to write an equation for the tangent line to the solution curve in part A at the point 0, 1. Use the equation to approximate f of 0.2. So here we're going to be doing linear approximation. We start out with the original dy dx equation, or the slope equation given in the original question, which is 3 minus y times cosine x. Then we plug in the point 0, 1 for x and y respectively, and we get that the slope of the equation at this specific point is 2. We take the slope that we just solved for and use the point that we have and plug it into point slope form, which gives us the equation y equals 2x plus 1. Now this is the equation for the tangent line of the graph at the point 0, 1. So to approximate 0.2, we just plug 0.2 into this approximate equation, the tangent line equation. So we have y of 0.2 is equivalent to 2 times 0.2 plus 1, which is equivalent to 1.4. The approximate y value at x equals 0.2 is 1.4. AP test, this question would be worth 2 points, one for the tangent line equation and one for the approximation. Again, the tangent line equation is derived from using the original dy dx equation given in the problem to find the slope, which is 2 here, and the point, which we are given at 0, 1, to find the tangent line equation, which is y equals 2x plus 1. That's 1 point. The second point is then plugging in 0.2 and approximating the y value at x equals 0.2, which here is 1.4. So part C tells us to find y equals f of x, the particular solution to the differential equation with the initial condition of f of 0 equals 1. So essentially this problem is asking us to differentiate the original dy dx solution given in the problem, which again is 3 minus y times cosine x at the point 0, 1. So first, we separated the variables, separating y to the left side of the equation and keeping x on the right. We then took the integral of both sides, used u substitution to solve for the left side's antiderivative, and we got negative ln absolute value 3 minus y equals sine x plus c. From this equation, we wanted to find out what c was, so we plugged in our values of 0 for x and 1 for y to get c is equivalent to negative ln of 2. Then we plug that in to get ln absolute value 3 minus y equals negative sine x minus ln 2, which gives you absolute value of 3 minus y equals e to the negative sine x minus ln 2. Because it's absolute value, we don't know if this e to the whatever is positive or negative, so we have plus or minus here when we solve for 3 minus y. So 3 minus y is equivalent to plus or minus e to the negative sine x minus ln 2. Then we get negative y is equivalent to negative 3 plus or minus e to the negative sine x minus ln 2. This part is pretty much just algebra. Then we get y equals 3 plus or minus negative sine x minus ln 2. This part we just divided by negative 1. Now continuing on over here, we got y equals 3 plus or minus e to the negative sine x times e to the negative ln 2. So in order to do this part of the algebra, you need to understand your exponential properties. Again, if exponents are added or subtracted, then we can separate them by having the same base and multiplying these two values together, e to the negative sine x and e to the negative ln 2. Thus we get 3 plus or minus e to the negative sine x times negative 2, which gives us y equals 3 plus or minus negative 2e to the negative sine x. Then we plug 0, 1 back into the equation to determine whether or not we need a positive or a negative there, or plus or minus. So in order for f of 0 to be equal to 1, we need a minus 2e to the negative sine x. In order to get that, because this is already negative, we just need a plus here so that this remains a negative. So our final equation is y equals 3 minus 2e to the negative sine x. On the AP test, this part of the question would be worth 6 points. 1 for the separation of variables, moving y to one side and x keeping x on the other. This 2 points for antiderivatives, making sure your antiderivatives are correct, and making sure you have plus c here. That's the thing a lot of people forget, which is not good, because you do need to solve for c, which is the next point, which is the constant of integration. You have to solve for c and get the correct value. That's 1 point. Then the next point is that you use the initial condition of 0, 1, whether it's to get c or to get whether or not this is plus or minus. And the last is solves for y, and we did, because our equation is y in terms of x, which is y equals 3 minus 2e to the negative sine x, and we are done. So out of the 6 points that are possible for this question, if you don't find the constant of integration or add c or solve for c, then the highest you can get is a 3 out of 6, which is the first point for separation of variables and the 2 points after for the antiderivatives. You cannot get any of the other ones. So that is not good. So always make sure you add c and solve for c. And if you do not separate the variables or don't move x and y to different sides of the equation, you will get 0 points out of 6, and that is not good. So make sure you separate x and y before integrating, and make sure you solve for c again, because that will cost you many points. For extra practice, you can visit these websites. I have put links to them in the description below. The first website is a College Board website that explains and gives examples of how to solve differentiable equations. The second is Khan Academy and explains how to do slope fields and how to differentiate equations. And the third of which is also Khan Academy and explains how to use linear approximation to approximate the value of a point. This linear approximation is like what we did for part B of this question. If you want more AP Calculus AB FRQs like this question, 2014 number 6, then you can go look at the AP Calculus AB FRQ 2016 number 4 and 2013 number 5. Thanks for watching!